afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. The next concept or next is planar graphs in discrete mathematics of graph theory. In this video, we are going to discuss about what is a planar graph, how to convert the given graph into a planar graphs, and we can understanding the concept of planar graphs by considering some example problems. So what is the definition of planar graph? A planar graph is a graph. Normally, what is a graph? Graph consisting of edges and vertices. It is a graph because it contains vertices and edges. Planar graph is also a graph which can be drawn on the plane such that no edges intersect except at their endpoints. Remaining edges should not cross each other. That means, in other words, we can say that it can be drawn on a flat surface without any edges crossing. That is the definition of planar graph. In simple words, we can say that planar graph is a graph which can be drawn on the plane, no two edges cross each other. So, what is the objective of planar graph? Means we need to convert the given graph into a non-planar to planar. Non-planar to planar. So, planar means no edges should be crossed. But what we are going to do, if it is a planar, then it is a non-planar, we need to convert into a planar graph without changing the meaning of the original statement of the given graph. Here there is a to B, no edge, B to C, no edge crossing, C to D, no edge is crossing, A to C, no edge is crossing. Then again we have to draw A to D. Then again C to B. If you draw from C to B, here edges are crossing, then you have to draw that edge from C to B from outside of the graph, C to B. What the edge is present from C to B, here also we can draw from C to B, but outside of the region without changing the meaning, then it is called as a planar graph. So before that, these are the crossing. But how we can converting this crossing of the edges to non-planar graph? By taking that same edge from the outside of the region, then it can call it as a planar graph. So considering some example, we need to check whether it is a planar or it is a non-planar. Here, these edges are not crossing because there is a vertex is present. So it is a butterfly graph. It is a butterfly graph. Here the edges are not crossing. This is a vertex is present. Edges are not crossing. It is a planar. Here also A, then B, no edges are crossing. No edges are crossing. It is a complete graph of K4. That means complete graph means every vertex in the graph is connected to all other vertices in the graph is called as a complete graph. It is also not a planar. It is also a planar graph because no edge is crossing. Here it is a complete graph of K5. K5 means 5 vertices are present. All 5 vertices are connected to all other vertices in the graph. It is a complete graph. Here some edges are crossing. Here this edge is crossing. Here also this edge is crossing. Here also edges is crossing. If edges are crossing, then we can call it as a non-planar or it is a not a planar. It is a non-planar or it is not a planar graph. Next, it is called as a utility graph. It is also called as bipartite graph. In the case of bipartite graph, so we have to take 3 edges, 3 vertices on the board, that is a top of the graph, and 3 edges on the bottom of the graph. Every vertex which is present on the top of the graph is connected to all other vertices which are present on the bottom of the graph. This is called as a utility graph. In the case of utility graph is not a planar because edges are crossing. Here this edge and this edge is crossing and this edge is crossing, so it is not a planar graph. These are the examples and differentiate between the planar and it is a non-planar. Then we have to considering some example how to convert a planar graph into a non-planar graph. Non-planar graph into a planar graph without changing the meaning of the edges which are present in the graph. So consider the second example. Show that the following graph is a planar graph and draw the plane graph of it. Okay. First you have to draw the edge from C to D. C to D, no crossing. Then D to E. D to E, no crossing. Then E to F. E to F, no crossing. Next. Again that. So we have to take from A to D. A to D. A to D we have to draw. A to E, we have to draw A to E. Then A to F, A to F. Here one more vertex B. Here there is a crossing. If you draw, there is a crossing is present. So we need to remove the B from the top of the graph which is drawn on the bottom of the graph, and we have to draw the edge from C to B. C to B. Before that there is a crossing. When we draw that edge on the bottom, then we have to get C to B, no crossing. Then D to B, also no crossing. Before that it is not a planar graph because edges are crossing. When we convert a not planar into a planar, no edge is crossing. So, but the same edges are present. There is no change of meaning because two edges are connected to B. Here also C to B is connected, D to B is connected, but edges are not crossing. It is called as a planar graph. It is a planar graph. Considering one more example, draw the planar graph for the following graph. So we have to start from the vertex 1. 1 is connected to 5. Then 1 is connected to 2. No crossing. Then 5 is connected to 4. 4 is connected to 3. 3 is connected to 2. Here no edges are crossing. All edges are drawn on the plane without crossing. Next, we need to draw from 1 to 4, no crossing. 1 to 3, no crossing. Okay. Next, 2 to 5. If you draw from 2 to 5, inside the graph, there is a crossing of the edges. So we have to draw from 2 to 5 like this, but without changing the meaning of the statement. Next, so all edges are complete 2 to 5. Then after that 5 to 3. 3 to 5. Next 4 to 2. 4 to 2. If you draw from 4 to 2 in this direction, crossing. Suppose if you draw from outside, also crossing. Then from 2 to 4 is also crossing. There is a crossing. Crossing of the edge. So it is not a planar graph. We can't draw it on the plane. We can't draw it on the plane. Suppose if you draw 2 to 5 and 2 to 4, then there is a no chance. We have to draw it with another way. We'll try in another method. 1 to 2, try with another method to draw the planar graph. So first of all, this is not possible. In another method, we'll try. Is it possible to draw the planar graph? 1 to 5, 2, 5 to 4, 4 to 3, 3 to 2. So this is one possibility. Again 1, 4, 3. Next 2 to 5. Draw like this. Next. Then 4 to 3 to 5. 3 to 5. Next 2 to 4. Not possible. There is a crossing. So we can't draw. Suppose if you try in any other alternatives, we can't draw the planar graph because if you draw like this, there is a crossing. If you draw like this, it is also crossing. So it is not possible to draw the planar graph. So we can say that therefore it is not a planar graph. It is not a planar graph. And if you try to draw in any direction, there is a crossing is present. So it is not possible to draw the planar graph for the given graph. So what we have discussed up to now, what is meant by planar graph, what is the definition of planar graph, how to convert the given graph into a planar graph, then we can understand in some example problems also. Thank you.